Welcome back. We're still working on cell voltages, and this is another question where they have us work backwards to figure out what's happening. We have a cell where lithium metal is oxidized to lithium ions, and that would have to involve an electron for the charges to balance out. And we'll get the voltage in a second. At the same time, they say metal Y ions, and we don't know what their charge is. Yeah, it'd be nice to know that, but we'll just assume they're +1. If they're +2 or 3, that really doesn't have any bearing on what the voltage is, so not that sensitive that we don't have that information. It's a little bothersome, but we'll be all right. At the same time, Y ions undergo reduction and turn into Y metal. Okay, so they say the total cell voltage for this is 3.84 volts. And we don't have this mystery metal Y. This isn't supposed to be yttrium. It's supposed to be some metal we've never heard of. So don't expect to find it in the data book. But we do have lithium. Lithium is at the absolute bottom of our data book, the redox table. And what it has there is Li plus turning into Li solid and producing minus 3.04 volts. Now we have the opposite of that. We have lithium metal oxidizing to lithium ions. And if a reaction is reversed, so is its voltage. So this would be giving us positive 3.04 volts. And the second reaction would be giving us some unknown amount of voltage. 3.84 minus 3.04 tells us that this Y reaction should be giving us 0.80 volts. Let's get that out of there. It wasn't unknown for very long. This reaction would be 0.80 volts, and this is how it would be written in the data book with the electrons on the left, so we don't need to do any additional flipping to make this make sense. So this reaction, whatever it is producing 0.80 volts, and if they ask what the metal is, you can look on your redox table at 0.80, and a reaction you find that matches this very well is silver. Silver ions gain 1 electron, turn into silver metal, and that produces exactly the voltage we're seeing. So this metal that we're looking at might be silver, and we even, by luck, were right about the amount of charge. Nice when that happens. What else do they have for us here? In a certain cell, fluorine gas is reduced to fluoride ions. Pause. Right reaction. Fluorine, F2, is reduced to fluoride ions. There's 2 F's here, so there'd have to be 2 here as well, and that charge had to come from somewhere. There must be 2 electrons on the left. So good. And an unknown metal X undergoes oxidation. To what charge? Not sure. Same problem as in the previous one. We don't know what metal X is, so I don't know what ion charge to put. +1 is probably all right. We'll assume this is as simple as possible until we need to change something. And they tell us the total voltage for this is 2.53. So this cell is making 2.53 volts. Fluorine is in our data book, and it's the very top thing. This is the strongest oxidizer we know, and it would be producing positive 2.87 volts. So what are we getting from the reaction X? 2.87 plus X makes 2.53. X would have to be negative 0.32 volts for the math to work out there. Negative 0.32 volts. If you want to make an equation out of that, it would be 2.87 from the fluorine plus X equals 2.53. To solve for X, subtract 2.87 on each side, and you'll get X equals negative 0.32. If you want to do that with proper algebra, that would be the way. Now, this half reaction produces minus 0.32 volts, but that's not what we'd have in the data book. Why not? Electrons are on the wrong side. Everything in our data book has the electrons on the left. So if we found this X reaction in the book, it would be X plus, picking up one electron, turning into X metal, and because the reaction was flipped, the voltage would be flipped as well. It would be 0.32 volts. I've been saying 2 this whole time. Rats. I apologize. Mental math kills. 187.53. This should be 0.34 volts. You've probably been waiting for me to figure that out. Sorry it took so long. I must be tired. Okay, apologies. So this is the voltage that we would have in our data book, and if you look in the data book at 0.34 volts, you find a pretty good match for this, copper. This time our assume it's +1 charge was wrong. It's actually copper 2, picking up 2 electrons, but that doesn't change the voltage. So if you saw this reaction occurring, you could make a fair guess that this reaction involved copper 2 turning into copper metal. Apologies again for the glitch here. I hope that didn't throw you off.